Hello everyone. Today we're going to be covering user-defined data types, and this is the very first chapter in chapter 13 for A levels you will do. So this is a pretty easy chapter and something that is usually frequently tested once every exam series. So there's two types of data types we categorize in A levels. So firstly, we have non-composite data types. What are these? So these are data types defined without referencing another data type. So this is known as primitive or user defined. So primitive is already created by the system. So integer, real, char, whatever, right? Those are primitive and user defined, such as a record for now, and we'll discuss later on other data types. So non-composite basically doesn't refer to any other data types. So this can be a little bit confusing to get your head around, so let's just discuss it using the different types there are. Firstly, we have something called the enumerated data type. And this is a non-composite data type where all the values are defined in a specific implied order. So for this chapter, you need to know a pseudocode for declaring and using this. So for here, we have a type which is identifier, which is equal to the open brackets and our values. So for example, if I wanted to store all the sandwich toppings I have in my restaurant, I could make an enumerator with sandwich toppings and have the three values: cheese, ham, and egg. And these values are not strings. So as we know, they cannot refer to a primitive or user-defined data type, so they're not strings. They're just values, almost like constants, okay? And they have an order. I'm specifically putting in cheese, ham, and egg. So if I have month, if I'm doing it for month, I would do something like Jan, Feb, March. And we'll learn why later, but we give it a specific order for storing it. So if we have an example, I declared this over here. I can declare my topping as a variable, which is of sandwich type, topping type, right? And we can set it to cheese over here. Now, what this means is my topping now has the value cheese. Remember, again, we do not put it in quotation mark. This is not a string or an integer or whatever. All right? And the special thing about it is this is not really storing the actual value. It's storing a reference. So when I store my topping, what I'm actually storing in my topping is something like sandwich topping 1, like an array almost. It's not an array, but for example, I'm storing a reference of position. So over here, when I assign this value, I'm actually storing the value 1, not cheese, the 1. So what I can do now is I can do my topping equals to my topping plus 1. So I'm incrementing it. And what this does is now my topping is referring to the second value, or the one after cheese, which will now be ham. So my topping is now referring to ham. So this is basically the use case of enumerators. Next, let's consider pointers. So this is very common in C# and C languages and higher level languages. We don't really learn it with Python or pseudocode. So pointer data types are used to reference a memory location and requires the data type being stored in the location. So imagine I have my memory over here, right? It's stored in blocks, and I have an integer here. What I can do is I can create a pointer variable which will store the location of my data. It's not storing the actual data, but it's just storing the memory location where my data is stored at. And if you remember from AS level, this is known as indirect referencing. So if you see, to declare a pointer type, what you would do is you would put a caret symbol and the data type. So we can see here type sandwich pointer caret sandwich topping. So what I can do now, type age pointer, something like this, for example, and this could be for integer. So I can store the memory location of an integer over here. Now what I can do is I can create a variable topping pointer and so store sandwich pointer. And now what I can do is I have my topping, correct? So over here, I'm using an enumerator and I have this variable. And what I can do is I can use topping pointer and the caret symbol, and this will store the location of my topping, the memory address of my topping into this pointer. Now, what you can do is something called dereferencing. So now that I've stored it, what do I do with this? What I can do is I can fetch the data that is being pointed at from the topping pointer. And so I can create another variable, for example, band topping. So this is a topic I don't allow. And band topping, and this is equal to sandwich topping from before, this is a numerator value. And that value is equal to the topping pointer backwards caret at the very end. And now this is dereferencing it. So if I imagine over here, I have my memories, and this is 1. So 1 is being stored in band topping. Sorry, not in band topping. This is being stored in the topping pointer, right? And now what I'm doing by dereferencing it is I'm getting the value that is being stored at in the memory location that is being pointed at. So what type of memory addressing is this? This is indirect. Topping pointer stores the address, and that stores the address of the data, right? So if you imagine, this is a bit confusing. If I have data like this, and I have 20, 21, 22, 23, 24, 25, 26, topping pointer, my data is over here. Topping pointer will store the value 21. And now when I get that, I'll go here and I will fetch the value from here. Alright, so that is indirect referencing. Now, covering to composite data types. So this references to any data type that uses another data type in its definition. So like last year we learned about records. This is an example of a composite data type because in a record, which is in itself is a data type, I can use other records. So strings, sandwich topping from before, integers, dates, whatever, right? I can use other data types, sorry. And the other two examples we will learn about are sets and classes. And later on in the syllabus, you will learn more about classes and object-oriented programming. So I'll just go over a brief overview. So you guys know from last year about the format of a record. So I have type with the identifier. I can declare fields for it, and then I end the type. So this is an example over here of a student record. I'm storing a student. I'm storing its name, its age, and its grade, which is a char. Now what I can do is I can declare a variable, say top student, and I can set individual values. So top student dot, and then I can access a specific field. So I'm accessing the field name and I'm storing it to Bob, similarly age to 17 and grade to A. Awesome. So that's how records work, brief and simply. Now the new type we have is sets. So a set is a list of unordered elements. So unlike enumerators, it doesn't have any purpose in ordering, and that use set theory operations. So if you were in maths or even in IGCSEs, you will learn, here, something like this. We have set A and set B. So I can perform functions like intersection, union, which gets everything, and all of that. And I can perform that on different sets. So again, pseudocode, we have a type, the identifier, so days, for example, and it will be a set of, sorry about that, and it will be a set of data type we want. So let's just go with string, for example, right? And then what I can do is I can define a set for that value. So define names such as weekdays for values. So let's go with an example. Instead of this, we can say days, and this will be of type string, of course in capitalization. Now I can define a set of days such as weekdays, right? And I can set these values to Monday, I have Tuesday, I have Wednesday, and so on for whatever values we want, right? And this is of an identifier of days. So it's like a general way of saying, if you have a pouch, right? I have a pouch that can store balls. And what I can do later on and define it by saying, hey, I will store a green ball in this, a red ball in this. But I know previously already I can store balls in it. So that's basically a type definition of a set. And over here you can see an example that I can store letters as a set, and it's a set of characters. And I can define a specific set of this, of vowels, which are A, E, I, O, U, which is a set of type letters. Now, the final and most likely the most complex to understand are classes and objects. So, in composite data types that include the variable and methods that can be run in the class. So, if you've never programmed before, this is a bit challenging. But what you can do is here, for example, I'm creating a class for a car, and then I'm storing a string, a make, so like a Toyota, a serial number. And what I can do is I can perform methods or procedures on that data which is stored in a class. So over here I can perform a procedure of this wasn't written here, which is get make get make, and then this will perform data that is already being stored in the class. So this will set the car make to this value, the car serial number, just re-say this, the car make will be set to the make value, the car serial number is being set to the serial value. So I can directly alter the data that is being stored. And you might be wondering about the private and public part. So public variables and methods can be accessed from anywhere in the program, even outside the class. So what I can do is, if you take an example, right? I have a public class, say, I have a student. I have a class of a student, right? I have a class of a student. I set name, grade, and a form. So in a private variable, it can only be accessed in the class they're declared in. So for our student here, I have, name, age, grade, class. So do I want everyone or anyone who's using this class to change a student's class? No. I want to keep it constant when it's created. So what I would do is I would create a private method to store set my student's class, and that would not be able to be changed outside the class definition. So if I private set class, something like this, and then I would set the class to, let's say, 11b or something like that, right? So this is setting the class, and I cannot alter it unless I'm calling it inside the class definition. Now on the other hand, I could create a public method for such as something like grade. So grade increment. So if my student has improved, I can call the grade increment in another program. So if I have another program which is marking test results, right? And if my student got over 90, I want to increment their grade. So over here, I can call the grade increment, and this will just do something like grade is equal to grade plus 1. So I can call it anywhere where I'm coding, I'm using it, all right? And that is the basic essence of class and objects. It's completely fine if you don't understand this, because we'll cover this later on in programming and later on in the syllabus. But this is definitely the most challenging, but it's important that you're familiar with records, you're definitely familiar with pointers, and definitely familiar with enumerators. These are all very commonly asked. So best of luck, guys, for your A-level exams.